Lesson 14, I will solve word problems involving the addition of measurements in decimal form. So today we are going to solve problems on our problem set. So today we're going to get our problem set out right away and we're going to look at those 4 problems and work them together. All right, so let's talk before we get out these word problems and let's think just a minute about some things that we're going to do. We're going to use the RDWW process. And the one part that we always have a little bit of trouble with is remembering to model the problem. So I want to make sure that you keep that in the forefront of your mind that we are going to be modeling today. All right, so let's start with the R and let's start by reading this problem. So barrel A contains 2 7/10 liters of water. Barrel B contains 3 900 liters of water. Together, how much water do the 2 barrels contain? So what is something that you could draw? I want you to think to yourself, what is something that you could draw? And I want you to go ahead and draw it and be thinking about how are you going to solve this problem. And when you have something drawn, I want you to come back and let's check together. Well, my first thought here was to use a tape diagram. This may not have been what you thought, but this is what I thought. I thought, well, this sounds like we're trying to find a total. So the first thing I did is I drew my tape diagram, and I labeled one of them A, and I labeled the other one B. Okay, so you can see here that I have A and B, and in the first one, I'm going to put 2.7, or 2 7/10, and then barrel B had 3 900. So I'm trying to figure out what they have together. So my question mark would be the total here. So what do you think I would do to try to figure out the total? Would this be addition? Would this be subtraction? What would this be? Well, if I want to find out what those are together, I would add them. So let's think about this for a minute. I've got 2 different units. I've got 2 7/10, and I'm trying to add that to 3 900. So before I can add, I'm going to have to find some common units, right? So what would I do here? Well, I can change those tenths into hundreds, right? So I could say, well, 7/10 is the same thing as 70 hundredths. Now I could add. If I add whole number to whole number, that gives me 5. And if I add fraction to fraction, well, that gives me 79 hundredths. So let's think about this for a minute. How much water do the 2 barrels contain? So let's write a sentence here. So I'm going to write it over here. The barrels contain 5, and I'm going to go ahead and convert this back to a decimal. 5 79 hundredths liters of water. Now, on the next slide, we're going to look at some other options of ways that you could have modeled this problem. Okay, so if you take a look, well, actually you can see that they chose to use a tape diagram too. And you can see that again, they converted their fractions or their decimals to fractions and then had common units and they added together. So they got 5 79 hundredths of liters. So these are just some different ways that you could have added these together. I chose to just go whole number to whole number and fraction to fraction. Okay, let's take a look at problem number 2. Alyssa ran a distance of 15 8/10 kilometers one week and 17 34 hundredths kilometers the following week. How far did she run in the 2 weeks? So I want you to pause the video and I want you to contemplate for just a minute what is something that you could draw. If you feel pretty confident in your solution of the problem, go ahead and solve the problem and come back and let's check together. Well, I saw this problem again as a total in a tape diagram. And you can see what I've done here. I've gone ahead and labeled week 1, 15 8/10, and week 10, 17 34 hundredths, and I was looking to find a total. So if I wanted to find a total, what would I do with these 2 numbers? I would add them, right? So hopefully that's what you thought to do. And let's see if we can't go ahead and add these. So if I've got 15, I'm going to go ahead and convert these to fractions, and 8/10 plus 17 34 hundredths. Well, before I can add, I'm going to have common units. Right now I have tenths and hundredths. So I'm going to change these tenths to hundredths by adding a 0 here. So now I have 15 and 80 hundredths plus 17 and 34 hundredths. Now I'm ready to add. So 15 and 17, well, I know 15 and 15 make 30. So in order to make this 15 and 17, that would be 32. And 80 and 34 would be 114 hundredths. So you can see this leaves me with an improper fraction. So I'm going to go ahead and create a number bond here, and I'm going to decompose so that I can make this into a mixed number. So this will give me 100 hundredths and I would have 14 left over. Okay, so you can see here I've wrote my number bond. Now this number right here, this is a 14. I know it looks a little sloppy, but this is 114 hundredths, and I've decomposed it into 100 hundredths and 14 hundredths. So if I take this 32 and I add that to this 100 hundredths, which would be 1, and then I add that to 14 hundredths, that's going to give me a total of 33 and 14 hundredths. So now all I have to do is write this as a statement. So how far did she run in 2 weeks? So I'm going to go ahead and just type that in right here at the bottom, and I'm just going to say she ran 33 and 14 hundredths, that's the way I'm going to have to do my fraction since I'm typing, kilometers in 2 weeks. Okay? All right, let's try the next one, problem 3. An apple orchard sowed 140 and 5/10 kilograms of apples in the morning and 15 and 8,500 kilograms more apples in the afternoon than in the morning. How many total kilograms or apples were sowed that day? So let's think about this for just a minute. I'm hearing some comparison words. Are you hearing those comparison words? If you didn't hear them, go back and reread and see if you can find some words that are showing that we are comparing. Well, I'm seeing this word, more. When I say I have more, you have more, there are more, I'm comparing. So I'm comparing the morning apples to the afternoon apples. So whenever we've used a comparison, we have used a certain type of tape diagram. We have used 2 tape diagrams to be able to compare. I want you to pause the video and see if you can draw 2 tape diagrams comparing the morning apples to the afternoon apples, and let's come back and compare our tape diagrams. Okay, did your tape diagrams look something like this? First of all, I want you to notice that my afternoon tape diagram is larger because it says in the problem that they sowed more apples in the afternoon than they did in the morning. So it says that they sowed 140 and 5/10 in the morning, and the afternoon they sowed more. How much more? 15 and 85 hundredths. So the question is not how many did they sow in the afternoon. The question is how many total were sowed that day. So this is where my question is. This is going to be a 2-step problem. Can you figure out what the first step would be? Well, my first step is going to be to figure out how many apples I sowed in the afternoon. So in order to do that, I'm going to have to take the morning amount and add 15 85 hundredths to that. So I've got 140 and 5/10, and that does say 10 even though it doesn't look like it, plus 15 and 85 hundredths. So right now I do not have like units. I have 5/10 and 85 hundredths. So I'm going to come back and I'm going to fix this a little bit because this is a little bit sloppy. Okay, so I've got 5/10. I'm going to change these tenths to hundredths by making this 50 hundredths. Okay, so let's add whole number to whole number. 140 plus 15 would give me 155. Fraction to fraction would give me 135 hundredths. So you can see that I've ended up with an improper fraction. I want you to pause the video and see if you can't change this improper fraction to an appropriate mixed number, and let's come back and compare. Okay, so hopefully you made a number bond and broke 135 hundredths down into 100 hundredths and 35 hundredths. If you take this whole number and add it to 155, that gives you 156, and then you add the fraction, so you have 156 and 35 hundredths. Okay, so let's write 156 and 35 hundredths over here in the afternoon amount. All right, so it's asking for a total kilograms of apples that were sowed that day. So what would I do with these two numbers to come up with a total? Well, I would have to add them. So I want you to pause the video and I want you to try to add these two decimals together and see if we get the same answer. So pause the video and let's come back and compare. Okay, so I took both of these decimals and converted them back into fraction form. I took 5 tenths and made it 50 hundredths. So when I added fraction to fraction, I got 85 hundredths. When I added whole number to whole number, I got 296 wholes. So together, 296 and 85 hundredths kilograms of apples were sowed that day. Hopefully you got the same answer that I did. All right, let's see how they chose to do this. All right, so you can see their tape diagram looks very similar to ours. Oops. And you can see that they added their 140 and 5 tenths to 1585. So it looks like here they did the exact same thing as we did. But in solution B, because 140 and 5 tenths was twice, they multiplied times 2 and then added 15 and 85 hundredths, which got you the same answer. You can see that solution B actually was a little more efficient, but they still got the same answer. All right, so let's look at our last problem here, problem 4. A team of 3 ran a relay race. The final runner's time was the fastest, measuring 29 and 2 tenths seconds. The middle runner's time was 1 and 89 hundredths seconds slower than the final runner's. The starting runner's time was 9 tenths of a second slower than the middle runner's. What was the team's total time for the race? Wow, I'm hearing so many comparing words. I'm hearing words like slower, slower, fastest. This tells me that when I'm modeling, I'm going to have to make sure that I can compare these three numbers. I want you to pause the video and I want you to see if you can draw a model that compares these three runners' times. Okay, so the first thing I had to think to myself is I had to really think real world for a minute, and I had to think, okay, so if the final runner's time was the fastest, that means that he ran the distance in the least amount of time. So you'll notice that the final runner's tape diagram is the smallest, because if someone ran slower, then it took them longer. So their box should be bigger. So the first thing you notice is the first clue says that the middle runner's time was 1 and 89 hundredths seconds slower than the final runner's. So this distance from here to here would have to be 1 and 89 hundredths of a second. Then it said the starting runner's time was 9 tenths of a second slower than the middle runner's. So it would be 9 tenths bigger than the middle runners. And the question is, what was the team's total time for the race? So I'm kind of thinking back to problem 3. And if you'll remember that each of these runners, they all ran 29 and 2 tenths of a second. But the middle runner ran 1 and 89/100 longer, and the starting runner ran 9 seconds longer than the middle runner. So it's kind of, if you could kind of think of the starting runner actually ran the slowest. So this person had 29 and 2/10. They also had 1 and 89/100, and they had an additional 9/10 of a second, if that makes sense. And I'm trying to find the total. So I could take a lot of steps. I could take 29 and 2/10 and add it to 1 and 89/100 and get the middle runner. Then I could add all three of these and get the starting runner, and then I'd have to add all three of those numbers to get the total. I could do that, but I'm also thinking I could use a little bit of multiplication to be a little bit more efficient. What if we did this? 29 and 2/10 times 3. Let's think about that for a minute. 29 and 2/10 times 3. That would be 29 times 3 plus 2/10 times 3. Well, 29 times 3, why don't you pause the video and figure that out, and then let's come back and discuss that together. Well, I got 87. Is that what you got? All right, let's go back and put that back in. All right, so we've got 87 plus, so 2/10 times 3 is the same thing as 2/10 3 times. So 2/10 plus 2/10 plus 2/10 would be 6/10, which would equal 87 and 6/10. Okay, so that's going to be this number added, this number added, and this number added. So I've got, this is the total for those three numbers. Now I still have to add 189, 189, and 9/10, or 1 and 89/100. So let's do that. All right, so we've got, let's do split screen so we can see everything here. So we've got 189/100 plus 189/100 plus 9/10. Okay, so let's change this to fractions. So that would give me 1 and 89/100 plus 1 and 89/100 plus 90/100. Okay, so if I add my whole numbers, I have 2, and then I'm going to have to add all of these fractions. I can already see that this is going to be an improper fraction. So let's try adding 89, 89, and 90. Well, let's be smart here. 89 is 1 away from 90, right? So if I did 90, 90, and 90, that's 90 times 3. That would be 270, right? So that would be 270, but I added 1 to 89, and I added 1 to 89. So I have to take those 2 away, and that gives me 268. If you don't believe me, pause the video and try adding all 3 of those and see if you get the same thing. So that's 268 hundredths. Well, I can take this improper fraction, and since these are hundreds, it's pretty easy for me to say, well, 200 hundredths is 2 whole numbers, and then I have 68 hundredths. So altogether, that gives me, this is 2, plus 2 is 4, and 68 hundredths. Okay, so now I just have to take that 87 and 6/10 and add that to 4 and 68 hundredths. So this is going to be the same as 60 hundredths. So 87 plus 4 would be 91. 60 and 68 would be 128 hundredths. That would be the same thing as 91 plus 1 plus 28 hundredths, which equals 92 and 28 hundredths. Now we have to do is just write our sentence. Okay, so what was the team's total time for the race? The team's total time for the race was 92 and 28, and 28 hundredths seconds. Okay, so my strategy may have been a little bit confusing to you, and don't let that discourage you. You didn't have to use this strategy to get the answer. You certainly could have found each individual runner's times and added those together. As a matter of fact, if we go and we take a look at what the writers of this program did, you can see that that is exactly what they did. You can see that right here, they added 29 and 2/10 to this 1 and 89 hundredths of a second, and that gave them 31 and 9 hundredths, which is the middle runner's time. And then they added 9/10 to that, and they got 31 and 99 hundredths, which was the starter runner's times, and they added all those together, and then they got 92 and 28 hundredths. You can see over here that they used the same solution that we did, or that I did. They took 3 times 29 and 2/10 and got 87 and 6/10 and added that to 46 hundredths and again got 92 and 28 hundredths. So there's more than one way to solve a problem. The important part is to remember that you have to really think through the problem and think about what they're asking, and then draw your model and go from there.